while Brother Eric sets up, let's just say a quick short prayer. Heavenly Father, we pray that as we gather here today, I pray for utterance even as I give this presentation. And I pray for understanding even in the audience today. In Jesus' name, amen. Okay, so we've been hearing about artificial intelligence for quite a while now. People say AI this, AI that. And it was I think it was a fantastic call by the leadership of the church to just for us to have a better understanding of what we really mean when we say artificial intelligence.
Is that the biggest? I don't know if you can get it.
So if you just make it full screen, that and the other button.
This one.
No, the two arrows, opposing arrows at the corner. Yeah, just right there. That one.
Yeah.
Perfect, thank you. So we've been hearing about artificial intelligence, and I'll just take a few minutes today to give a general overview of AI in general, what we really mean when we say artificial intelligence, the kind of AI that we actually use, because there are different types, and how AI can be leveraged in our daily lives, for work, for personal lives, and even in the church for spiritual growth. Take the context, please. So these are some of the things we're looking at: the evolution of AI, subfields, how it works, and so on. Next. Thank you. So this is quite word heavy, but I just kept all these words there for people that would like to look over the slides again for a better understanding. But what all of this just means is, when we think about artificial intelligence, we're thinking about, and people say that AI mimics human intelligence, and that's somewhat true, but it's not completely true, because intelligence isn't just computing based. We have so many things that factor into our intelligence as humans, like our emotions, our morals, and so on. But what AI stands to do is to take the computing element of human intelligence and attempt to replicate that. Basically, what the main part being that humans can learn something and then make informed decisions based off of what they learn, and that's what we're trying to, or that's what we've been mostly successful with when it comes to artificial intelligence. You can train a machine, giving it examples, and it can learn from those examples to make decisions. So that's the part that we are replicating when we talk about artificial intelligence. And artificial intelligence will never is a strong word, never say never in science, but it's very unlikely to ever replace human intelligence, since there is an intangible part of intelligence that a machine would never possess. So AI draws from various fields such as computer science, mathematics, neuroscience, and linguistics to create machines that simulate cognitive function, just like I mentioned. So it's very multidisciplinary, and I think this is one of the reasons why it's really easy for people in different fields and domains to be adopted. You have people that have English literature degrees getting into artificial intelligence. In the company I work for, we have people that have English as a first degree and then AI as a second degree, and they perform really well. So there are different types of AI. So when we say narrow AI, this is what we are going to mostly be using as humans. Narrow AI just basically means that we have a model, we call the model the lower level. So AI is kind of broad, but when you have a specific use case for AI, we'll just say it's a model. So most of the applications that we have today do just one specific thing. You have, say, although ChatGPT now is more generative since it does images, but in the earlier days of ChatGPT, you could only communicate with text and you can only give text back. So that's narrow AI. It does one thing, anything text-based, and it's probably going to do well with it. But now we're kind of gradually moving into generative AI, and we hear it, generative AI or general AI, where now you can do multiple things. You can tell ChatGPT, create an infographic for me, and it returns that to you. Edit this image, it returns that to you. So it can handle text, images, and even return images to you. It can help with I think videos, I don't use it that often, but I think you can have videos with ChatGPT, and so on. So it is now, it's not just being limited to one thing. It's doing pretty well with generating different data types. Yeah, and we're going to be seeing more of that even as we move on with artificial intelligence in general. But most of the things that you would use are things like voice assistants, like Siri or Alexa, and those fall under narrow AI. Okay, so let's look at the quick evolution of AI. I won't linger here, but this is just, all the information is just for reading later if you'd like to. So, contrary to what people know, artificial intelligence, well, AI has been proposed for a long time now, about 80 years. It started with Alan Turing being, obviously being the father of computing. He thought about the possibility of replicating the computing aspect of human intelligence, and then he started proposing he published a paper, Computing Machinery and Intelligence, and that led, after a few years, to a few scientists, mathematicians, and so on. Some of those that are really popular, like McKinsey and all. And they came together at a conference at Dartmouth, and they decided to think about how they would actually start up the field of artificial intelligence based off of Alan Turing's paper. And so in the 60s, it started to really pick up. We have I'm not sure if anyone's heard of Eliza and Sherdu. They were one of the very earliest chatbots, and they were very simple, but they could simulate intelligence in the lowest basic form, in the sense that if you gave it a prompt, it returned something to you, and it was really exciting in those days. But over time, it wasn't that efficient, so it became less relevant. And so in the 80s, and we also had like expert systems where they use things like statistics, like Bayesian networks to try to also simulate artificial intelligence. But most of those things weren't that relevant, and that led to the AI winter in the 80s that meant there was no development, no progress, simply because we didn't have the computation power in terms of the actual electronics. And then when transistors were made to be more efficient, we saw a rise again in the 90s, where we started getting more momentum. We started having better algorithms. We started having more data, started collecting more data. And then IBM developed the Deep Blue, and that beat the world chess champion Garry Kasparov. And so in the 2010s again, we had another spike in interest in artificial intelligence, because once again, computing, we started having people use GPUs more, and so there was the opportunity to do things like deep learning, which OpenAI and some of these companies that are now very popular started doing while they were in the infant stage. So we started using deep learning. We started, exploring with creating really specific artificial intelligence applications that could do things very well. For example, just off of what IBM did, AlphaGo did something similar that was able to beat a human champion in Go. And some would say objectively Go is a bit harder than chess, so this was also another strategic milestone. And in the 2020s, we've seen even more growth in terms of transformer models, ChatGPT, DALL-E, and so on. And we've now seen the AI expand into other fields like healthcare, finance, and we'll see all of that soon. Healthcare, finance, education, and even in the creative industry. And what we expect to see in the next coming decade would be more human and AI collaboration. Obviously, there would be instances where we'd have even more adoption of AI and some people would be out of jobs. But just like it was when the internet first came out and there was a transition, there definitely would be a transition period, but we'll definitely see more human AI collaboration as we move forward, and we will have more generative intelligence than we do now. And yeah, definitely stronger AI regulation and ethics, because that's super important. So let's look at some subfields of artificial intelligence. And these terms are really important to really understanding when people say things like machine learning, deep learning. I didn't include data science because it's like the general grandfather field, but I would explain how all of that ties together. So first of all, machine learning. There's a kind of a chicken egg scenario because you have to think about which one comes first. We use machine learning to train AI models. So would you say machine learning is part of AI or AI part of machine learning? Either way, machine learning is super important to artificial intelligence, and it's the bedrock of AI. So the kind of machine learning model you'd use will determine how well your AI application functions. It determines the one you choose will determine the direction that you're going to use for your artificial intelligence model. Maybe you're trying to do some prediction, you're trying to have a better understanding of something, and so on. So it creates algorithms, and algorithms just means the specific instructions that the computer has to follow. So it creates algorithms that allow the computer to learn from the data and then improve their performance over time. So just like a human child would learn the color orange and yellow and red and so on, just by interacting with those colors and having them being labeled as they are, that's exactly how the machines will learn based upon the algorithm. So they'll learn how to identify, depending on the data you put in, if it's images, it'll learn how to identify maybe cat images over time or dog images over time. And if it's maybe financial data, you're trying to find instances of fraud. And that's why when there's an unusual activity on your card, you get a call from the bank or something's wrong, because they've trained their machine learning model to understand this is what normal behavior looks like, and this is what abnormal behavior looks like. So when abnormal behavior happens, based off of what it's learned, it can flag that. So that's how important machine learning is. And it also includes things like spam email filtering, and even things like recommending what shows to watch. So it learns the kind of shows that you like. Maybe you're the kind of person that loves watching like crime documentaries and so on. When a new crime documentary comes out, you probably want to be one of the first people that it's recommended to, based off of what you already watched. So machine learning is really important for artificial intelligence systems, and most of them have a continuous pipeline that allow the model to continuously learn from data. Now, natural language processing. Natural language processing is probably the kind of AI that you interact with most commonly, especially if you use things like ChatGPT, Copilot, Gemini, Coral, and so on. So if you use those ones, you are interacting with a natural language processing model. So, and what NLP does is allows computers to understand, and NLP is one of the oldest, probably the oldest subdomain or field of artificial intelligence, because, and it's super important because we want our computers to understand human language. We're trying to close the gap of the language barriers, and I think even sometime in the future we'll be able to actually write code without having to write it in some specific computing language. We might be able to write code in like just plain English if it all works out. So NLP allows computers to understand, interpret, and generate human language. So there's a lot that goes on in the background, but the whole point of natural language processing is that you give it text data, it understands what you mean, and it can respond appropriately. That's why if you tell ChatGPT, help me restructure this email, it understands the context of the email you're trying to send to your boss, and it also understands the general grammar rules that allow you to change a noun that's been put in the wrong place to maybe a verb or something. So the whole point of natural language processing is to be able to understand human speech, and we even have things like speech to text. That's also natural language processing, because when you're speaking, all it does is to convert the audio signals into text that it can understand. So the transition has to eventually still be text that it will take in, but it's a pretty short pipeline from just normal text. And so it can do things like speech recognition, language transition, sentiment analysis to understand how a person feels from their voice. And this is why a lot of these large language models like ChatGPT, they sound human because it feels like they have an understanding of what you're saying, even though it's basically just ones and zeros. That's it. It's like talking to your phone or something. Yeah. So examples: Siri, Alexa. You also have language. I think I triggered my Siri. Sorry, excuse me. Yeah, and you also have language translation services like Google Translate. So if you travel to maybe Spain or something, you can give your phone to someone to say something, and then it's translated to you, and you can go back and forth like this. It was super important for me when I went to Japan. So it makes our lives easier, that sort of thing. And it's all on the back of natural language processing. Without NLP, we would not be able to do any of that. Computer vision. Now, computer vision is probably one of it's the second most important field of artificial intelligence, and it's probably one of the bigger ones. I think it's much easier for people to build a natural language processing model, since text data is very readily available, and the libraries that are used for that are very simple to understand. But computer vision there's so much space for growth. So I'd say if anyone wants to really get into artificial intelligence and be one of the people that are sought after, computer vision would be the way to go. So it teaches machines to interpret and make decisions based on visual data. So not just images, actual visual inference from a camera. And it can do things like identifying objects in images, facial recognition, and even medical imaging. I'd say one of the applications would be maybe in your cars, if you have like a more recent car that can, maybe like a Tesla or something, it does this thing on autopilot where it can identify like obstacles and objects as you move along, that sort of thing. That definitely is computer vision. Or maybe your car can automatically park. I think there's a phone that does that can park, even parallel parking on its own, unassisted. So it uses computer vision for things like that. And this is why the cars of the future will be very heavily reliant on computer vision, because now we can see applications where even for parking, it's already doing that unassisted. Yeah. So, and it's also super important in the field of medicine. Although I'd say, since there's a very little error tolerance for medicine, it's not heavily relied on. But having these kind of models would be kind of like a second opinion to what a doctor would say. It could never replace an actual doctor, but if a doctor wanted more information, you could use that for medical imaging. For example, for breast cancer, one of the most popular uses of artificial intelligence in medical imaging would be for things like breast cancer, where your doctors might miss things because of how the lymph nodes are structured in the breast. So for a second opinion, they could actually consult an AI model to look at all the medical images that are available. So X-rays, MRIs, and so on. So these are super important. These are the two main fields that I'd say computer vision would really, really lend to and can be super important in saving lives and so on. Robotics, finally. Now, robotics is not exactly a branch of artificial intelligence. Robotics is under a control system, which would be under electronic and electrical engineering, but there's now some sort of integration, and we now have robots that actually leverage artificial intelligence to function. We're seeing that more often, but it's not something that is also heavily relied on. Contrary to popular opinion, many of the robots that you see do not have any form of artificial intelligence. It's just smart computing, where the robot has things like, and its control system, it has maybe like a positional inference differential, PID. And so it allows it to perform, to stabilize itself and so on. So it doesn't have to have any form of artificial intelligence to function. But when the AI part comes in, things like having a better understanding of images and so on, and also being able to speak. Now, usually for robotics, it's mostly just narrow AI that's being used. So that's why when you have what's the popular one? The one that speaks. I don't remember, but one of the very first really popular ones that came out was a robot that could speak, but you found out that she couldn't do anything else. It was really popular, it was an Oprah and song. Yeah. So all she could do was speak and just move. So it's not as though we're going to have Terminator robots anytime soon. Maybe the next 100 years, I don't know, who knows. but no Terminator robots. And most of the robots that you see that perhaps look too good to be true are probably too good to be true. People wear like these costumes and they do things. So chances that we're going to have any robot uprising is very far into the future because they're still trying to balance the computational workload of running an AI model with the computational workload of having a control system that can function on its own. So it's a very huge trade-off. Okay, so how AI works in a nutshell, and this is just so we understand the pipeline that it goes through. So we collect data, any kind of data. Say you're trying to build an AI model that can differentiate between your two pets. Maybe you have two pets and you want to feed them something different, and you say, okay, I want my feeder to know what pet is what and can differentiate what feed comes out or whichever one. Maybe you have a dog and a cat or something. You collect the data, that would be maybe images of the first pet. You're going to need a lot, maybe like some 10,000, 100,000, but that should suffice, I think, for a small model. You have one of your dog, one of your cat, collect the data and you make sure you pre-process the data. You don't have to worry too deeply about how you do that until you get to the project, but the whole point is like you take the examples and you have them ready to go into, to be trained, to train the model on those examples. So you definitely have to have the examples of what you're trying to train to identify. And then for the model training, that's when you actually you choose an algorithm. The most popular algorithms that are being used today would be neural networks. I'm sure some of us would have heard of neural networks or deep learning. It's also something that's pretty popular, and people say it's supposed to be like a human brain, but I'd say not really. But the whole point is that it can allow data to pass through its neurons, very similar to how a human's brain works. That's mostly just it. There's a threshold for activation, and that's as much as the similarity with the human neural network goes. But you can use a neural network, you can use a deep learning network. If you don't want to use a neural network, you can use like a support vector machine, different kind of algorithms depending on what you want. So there's a host about, the most popular algorithms are maybe 20, but you have choices of algorithms to determine how you will be training your machine learning model. And then during the training, it starts to understand pattern recognition and it extracts features. So for your cat, it understands how your cat looks like in terms of its colors, what the ears look like, what the feet look like, and so on. And the same thing for the dog. And once the training is done, now it's equipped to actually make decisions and make inference based off of what it's learned. So now it knows what your dog looks like, knows what your cat looks like, and it can determine what feed to give each one of them. And then finally, like I mentioned, most AI systems would allow some sort of learning and improvement. You can say every time it gets it wrong, you want it to do something else. Or maybe every time it sees your cat, you want it to take a snapshot and also learn and train. Perhaps your cat changes over time and maybe it gets this something different. Yeah, so that's basically how it works. Data collection and pre-processing, model training, understanding the patterns and allowing it to make decisions and also learning and improving. So the AI industry, one of the reasons why I believe everyone should at least have an introductory knowledge of artificial intelligence is because most industries are now adopting AI into some form or the other. And for the industries that are trying to, whose main reason for adopting AI is to reduce staff and save money. It's someone that has the knowledge of how the AI system works will probably stand out. So it's important to, well, because nobody just leaves an AI system in their company just running amok. You have people that are maintaining, you have people that are doing feedback of how well it's performing. If, for example, people want, maybe a company wants an AI system instead of a secretary, there definitely would be people that would check in on how well it's performing over time. So that can be really, really important. So it can help with like automating processes that aren't really, that humans don't really have to do. Things that don't require emotion or critical thinking. You can automate that. It can improve decision making, enhance customer experience. I know not everyone likes to discuss with like an AI voice in the phone, but I don't mind. It really helps with the customer experiences, and it can assist, like I mentioned before, in diagnostics, drug discovery, and so on. There's this really huge site somewhere, I think Switzerland, where they have a scientific discovery system, or the entire thing is completely AI one. They make drug discoveries every single year. They're trying to find out how to beat cancer, and they've already been able to go really far in terms of understanding how cancer works and how drugs work with it. 24/7, you don't need a person to actually do that. So we now have AI researchers that work in specialized environments. So it really helps with that. So for financial users, we have fraud detection and so on. And even now, about 35% of companies are using artificial intelligence, and that lets you know what would you expect in the future. Just like when the internet came out a few decades ago and very quickly was adopted within a decade, we can expect that in the next 5 years, by 2030, most companies would have some form of artificial intelligence on their own. So it's good to really get ahead of that. And now we have the stats that show that 20 to 40% of companies see an increase in 20 to 40% in productivity when they use artificial intelligence. Not just in place of actual human doing the actual work, but even in conjunction with. Some companies now tell you if you want to write an email, use Copilot. A lot of companies now, some of the work that my company actually does is to build specific large language models for other companies. So companies like maybe Amazon would say, our technical staff usually have like 1 billion questions a day from the services we have, the errors and everything. And so what we do is that we create an actual large language model for them that they can query. So when they have a problem, I'm getting this error, it can return troubleshooting steps that they can take and so on. So not just in place of humans, but in conjunction and collaboration with humans. So it really helps with increasing productivity and even streamlining operational workflows. Okay, so how can you use AI in our daily lives? If you don't work in a company that's using AI, you can also make your life a bit more efficient, like a smarter daily routine. I have an Alexa in my house that wakes me up and really serenades me with classical music as I wake up. It's really nice. But if you don't have a voice assistant, you can to set reminders, because I like to be super organized, and I know I wouldn't remember everything I have to do, so I have alarms and reminders for every single milestone on my day. Even to eat, I have an alarm for that. So if perhaps you don't have an Alexa that does that, you have your phone, and most of our phones have maybe Siri or the Google version. Yeah, I don't know what that's called, but you have that on your phone. Yeah, Bixby, thank you. Thank you. So you have that. You can tell it to remind you for the things you have to do in the day. You can also do things like, something else I do is I dictate things that I have to do, like, open my notes. This is my shopping list. I want to buy apples, this, and it really writes that down. So even while I'm on the go, I'm doing things and I remember something, I don't always have to look around for things to write it down or find my phone. I literally just dictate what I want to be written. So that's one of the ways that you can make your life super easy. Just call Siri, Siri, open this up. Siri, remind me to call this person this time. It makes your life super easy. So if you have perhaps smart lights, and you don't have to be connected to like Alexa or something, but if you have smart lights or those little smart bulbs that people use to like, be more energy efficient, if you find the ones with voice commands, they usually have some form of will allow you to connect to like a larger AI system like Alexa, and you can tell Alexa, switch off my lights the next 15 minutes. I'm going to bed, turn off the lights. It helps with like energy savings and everything. And you can also check on your phone if you go out, if your lights are on. And you can tell Alexa through your phone if you have it out to switch your lights on. So it makes your life good. Yeah, so I already gave an example of the morning routines. I like my morning routine, so I have Alexa play music when I wake up and really prepare me. So you can also use AI for easy commuting and travel. If you use Google Maps or WAS for real-time traffic updates, you can ask Google to give you updates on traffic if you drive, or updates on closures and on the road, or maybe train disruptions if you take the train. You can also get travel recommendations. You can plan your route using ChatGPT. Usually when I travel, I tell ChatGPT these are the things I want to do over the course of maybe 5 days. Can you plan a route for me or plan an itinerary for me? And it works. You can also use it for things like lane assist, like auto braking, if your car has those features. I've seen to really take advantage of them. Or you can also use artificial intelligence for more efficient work and study. This is probably where I use ChatGPT or like AI system, not just ChatGPT, like Grammarly, more heavily to summarize things. So if I have a large document, I can have it summarize everything on the document, just giving me key points. A lot of the work I do is heavily research-based, and we're expected to read research papers and understand how these things are working and find out how those we can use those methods. And instead of having to read so many 10-page research papers, I just say extract the relevant points in this document and return it to me, and I can do all of that more efficiently. You can also use AI writing tools that allow you to brainstorm, like Notion, or if you have Gemini, I think Gemini is also pretty good for that. You can have to brainstorm ideas, you can summarize notes, you can draft documentations, and so on. It can also help automating scheduling, like Calendly, Google Calendar smart suggestions. It also helps you if you have this, if you use Copilot, if you have things in your calendar, you can really create a draft of what your week looks like, and I think that's important. For smarter money management, there are budgeting apps. You can set up your fraud alerts on your bank's AI security system. I have that on. You can try a robo-advisor and so on. And you can also, I'm pretty sure we already do this already. You can use artificial intelligence, those especially LLMs, to proofread emails, for reports, for presentations. You can ask you to grade your assignments and see how well you perform, and provide suggestions on how to make it better. So in the church, how we can leverage AI in the church? Similar to how we can use it in our daily lives, just about tuning into our work with our spiritual growth. You can use ChatGPT to summarize Bible passages. Obviously, it doesn't replace the Bible, but if you have a chapter and you're trying to understand the general theme of the chapter, you can tell it to summarize what this chapter says, or compare how maybe there are two separate accounts, maybe Matthew's account and John's account, and you want some sort of like a extra reasoning. You can say, oh, how do these, can you draw parallels from these chapters, and also extract insights. It's just, once it has the data you're interested in, you can just return things that will be relevant to you. Also for evangelism and outreach, so these can be used, if you have church website, you can have a chatbot that you can interact with. The other people that are not even in the church can go to the website, ask questions about their work with God, and actually get responses. Responses based off of, it's been trained on the data from the church. So it's not just like, responses from anywhere. Data from the church. It could be very church specific. We could say, okay, only Vine Branch messaging. We train the AI model on only Vine Branch messages. And so when someone asks a question, it's given the kind of response that a pastor in the church would give. Obviously, it doesn't replace the pastor, but in situations or circumstances where the pastor cannot be present to answer all the questions, it's a good substitute. And it also helps with breaking down language barriers. If you give the chatbot a multiple languages, to someone that speaks a different language can understand and also take part. So it can also be used for note-taking when we have our weekly midweek services. You can use it to take notes from those that aren't able to join, and it can also be used to summarize sermons, make it bite-sized so other people can, easily just after church go through the notes and everything. It's also good for content creation. I'm sure sister So it can be good for content creation using tools like Canva. I use Canva for this. Although I did it the hard way, I probably should have used the AI feature, but it didn't occur to me. But yeah, Canva, you can also use it to brainstorm social media ideas. You can say, I have this youth meeting I'd like to have. What are fun Christian games that we could do? Just things that you wouldn't immediately think of. It can help with that. And also for personalized discipleship, if you have, it can recommend Bible reading plans. If maybe you say, I'm going through a season where I have to be patient. Can you recommend some Bible verses in the Bible that reference patience? And it can bring all of that to you. And also if you have theological questions, like I said, it can't be just general information. You have to give it specific, you have to train on specific theological data. But with theological questions, it can also help with answering that. And my final slide. Yeah, so the limitations of artificial intelligence. Most of the things that we've been talking about when we've said AI in the past few slides have been large language models that we can interact with human language. It's sending it a text prompt and it's returning something to you. And some of the limitations are, it's just data, so it definitely lacks human judgment and emotion, so it's not able to replace actual human conversation, especially when it's a kind of a situation where someone would rather or should rather speak to like a pastor or someone in leadership about a specific problem they're having. It can be a very temporary substitute, but it would not replace the actual role of humans because it doesn't understand emotions, ethics, spiritual nuance. Not all questions are black and white. None of scenarios are black and white, but this is literally ones and zeros, so that's the definition of black and white. So you need that extra understanding from a human. So it's really limited in areas that require empathy or moral reasoning. And bias. So this is one of the biggest limitations of AI systems, especially large language models. Bias, since it's trained on specific kinds of data, if there's a bias in that data, it also translates to the model, since it's not something that has its own capabilities. It's literally just an intelligent way to return the data that you've trained it on right back to you. So any bias in the data would translate into the actual AI system. And you also have over-reliance and dependency. When we get too reliant, especially when we get really comfortable with just having our phones in our hands and being able to query something, being able to do something, it takes away some of our critical thinking skills, creativity, decision-making. I remember I was in a conversation with someone and he said, just pause, let me ask ChatGPT, and it was the most bizarre thing to me. Because in a discourse, an intelligent discourse, you expect people's thoughts and opinion. But he said, I'll just confirm with ChatGPT. And I said, you don't have to be right, just share your thoughts on something. Yeah, so our over-reliance on artificial intelligence is something that we should definitely take cognizance of. I mostly use it in physical tasks I couldn't be bothered to do, but I try to use it less when I have to reason or think about something. I prefer to use my brain. Our brain is the best computer in the world. And yeah, God knew what he was doing. So privacy and ethical concerns, when we share something with an AI system, even just giving it access to things like our lights and everything, you have to be very careful because it's taking data. It has your location, it has all the text that you've ever given it. So if you're chatting with ChatGPT, it has a history of everything. I know that they have data centers that store it for like a few, maybe months, but imagine if there's a breach, it has all your information. We're already in the age where your information is probably not even private anyway, but why should another company have access to your private information? If you can help it, I'd say to not share sensitive, very sensitive data with any AI system, and if you're going to be using ChatGPT for something you'd rather not allow it to keep, or even Gemini, they have this temporary button that you can click, so it saves no history of the conversation, and it's once you send the prompt and you move away, it's done. So I'd say to do that. And lack of contextual understanding. So for people like us that are Africans and we think a certain way, and most of these popular AI systems are trained on the Western ideals, so there's going to be some disconnect. So cultural differences, deeper meanings, and it can lead you to misunderstand or not even give very relevant responses. And finally, the high cost, and this is the last thing, because for most of us, we wouldn't have to actually spend money on AI systems, but for people that would like to develop things, create applications and so on, you have to spend money for the technical skills, the computing you need, storage you need, and even for expertise when actually creating these AI systems. Thank you.